Hello class, welcome to today's lesson. Our topic for today is locus of given point, part 2. In case you miss out on part 1 of this series, you can check out on our previous lesson to learn part 1 of this series. For part 2, we are going to learn second and third fundamental theorem of locus, as well as solve locus related problems on theorem 2 and 3. A quick flashback on our previous lesson. We learned that locus is the set of all points whose coordinates satisfy a given condition. That is to say, locus are a set of points that follows a particular pattern. Okay? We also learned theorems of locus to be 5 in numbers. That is, you can as well call them conditions or rules of locus. We focus on theorem 1, which says locus of points equidistant from a point P will form circle with center P. So I'll urge us to check our previous uploads on locus so you understand theorem 1 of locus. For today, we're going to focus on theorem 2 of locus. You can as well call it a second theorem of locus, which states that the locus at a fixed distance d from a line AB is a pair of parallel lines at a fixed distance of d from line AB and located on either side of AB. So what this means is that a point y can move so that it is always d unit from a straight line. Okay, unlike theorem 1 where we have a fixed point and the locus other points are moving around that fixed point. In this case, we don't have a fixed point, we have what? Two fixed points that makes up a line. Remember, the distance between 2 points is a straight line. So we have a straight line where other points move around it. So what theorem 2 is saying is that when points move around a straight line, they form parallel lines. Okay, a good illustration is the figure display. You notice that line AB, line C1, C2, and line C3, C4 are parallel. Okay, and also the distance between line AB and line C1 is equal to line AB and line C3, C4. All right, D1, D2, D3, D4 are all equal distance. So that is just what theorem 2 is all about. Let's solve a simple classwork so you understand what theorem 2 is saying exactly. The question says, draw the locus of all points exactly 2 centimeters from the line XY. So what you do, you need some basic materials. You need a pair of compass and a pencil well fitted on the compasses. We also need ruler. The question says exactly 2 centimeters. So that means we are going to extend our pencil, our compasses rather, to 2 centimeters. Okay. Then we dive into the solution proper. We draw our line XY with a compass extended to 2 centimeters as radius. We fix the metallic edge of the compass at X. We draw a circle. So the radius of the circle is 2 centimeters. With that same radius, we go to Y, place the metallic edge of the compass, draw a circle. Same radius, 2 centimeters. At this point, we join the circumference of the two circles at the top and at the bottom. The first point, the second point. We get our parallel lines to line X, Y. You notice that the distance between the first line and the last line are 2 centimeters apart. If you remove the circles, you get your shape. All right, so let's see theorem 3. Theorem 3 says the locus of points equidistant from 2 points P and Q is perpendicular bisector of the line segment determined by the 2 points. All right, so what this is saying is that when you are given 2 points, that means in locus, when we mean 2 points, remember the distance between 2 points is a straight line. So in most cases, like in exam condition, they might say given 2 points. It's the same thing as saying like given a line. All right, say given 2 points, the locus of point is a straight line midway between the 2 points. All right, so a line that can divide a given 2 points in the middle is a locus. All right. For example, we have line PQ. Line D1 and D2 divides and bisects line PQ in the middle. So that is what theorem 3 is saying. Let's solve a simple problem on that. It says draw the line PQ equal to 6 centimeters and find the locus which is equidistant from P and Q. So what do? We draw our line 6 centimeters. Okay? We use our compass, extend it to half, more than half the length of the line. All right, so the half of the length, the length of the line is 6 centimeters. Half of it is what? 3 centimeters. So we need more than that. So the compass should be extended more than 3, either 4, 5, or all 0.5. All right, so we extend our compass to maybe 4 centimeters. All right, because it's more than half, which is 3. We create an arc. You see, we at point Q create an arc on top of line PQ, create another one below it at that same distance of the compass, at that same extension of the compass. We start at point P, create another arc on top, create another one below. You see that the arcs intersect each other at a point N1, N2. So what we need to do is just to get our ruler, join points N1 and N2 to get our straight line, which is the locus. Okay, so solution 2 is telling us that the line N1 and N2 is the locus, which is equidistant from line PQ. All right, so that means from P to the middle is same thing as what? From the middle to Q. So far, we are able to understand locus, second and third theorem, and we are able to solve simple locus related problem. So let's try our understanding to really see if we understand what we are doing by taking these 2 home exercises. Thank you very much for taking the exercises. Until we meet again in our next classes. Bye.